Hello, welcome to this live technical discussion series. And today we are going to talk about IS 1893 Part 2. So we had very interesting discussion in the last session wherein we talked about draft standard IS 1893 Part 1. And as we all know that there are significant changes made in this draft standards. So we have an opportunity till 25th June wherein we can share our inputs to BIS technical committee for making the appropriate changes in this document. So as we discussed in the last session, I just tried to highlight few of the practical difficulties which we may encounter if the document is published as it is as a national standard. So today also, firstly, we'll be talking about IS 1893 Part 2. And just let's try to see a finer points, whatever I have observed, which may appear as a practical difficulty in the future if the document is published as it is without any changes. So meanwhile, you are also requested to share your finding, your understanding, or let's say your comments related to this document in the live chat. Yeah, yes, welcome Dr. Subramanian Narayan sir. Very good evening. Okay. And let me thank you, all of you, for showing great response to this discussion. So we have received nearly 530 plus registration for this event. So that itself shows that everyone is concerned about the changes in this document. So what we'll do in the next part of this session, let's say if time permits today, then I'll quickly show the input which we have received from different participants. Of course, we will not be able to read all the points, but I'll just quickly read few of the points, and we are working on that. And still we have time up to 25th June, so we are planning couple of more sessions on this, wherein in couple of more sessions we will be addressing the specific queries, or let's say what could be comments on these documents which may be sent to BIS technical committee from the perspective of the practical difficulties, right? So that's what we'll be planning in the next couple of sessions. Yes, very good evening, Naresh ji. Yeah, so I'm glad that you like all the videos. So in fact, it's only because of support from all of you that we are continuing this series. Okay, so thanks a lot for your comment. Okay. Okay, Dr. Subramanian Narayan sir is telling it's very important that many people attending this webinar and send their difficulties to the BIS committee so that this part 1 and part 2 of IS 1893 will not be accepted in the present format. Yes, absolutely right. Everyone. So it's not going to happen that, let's say, if one or two people write to the BIS technical committee, everyone from the across the country must write from their perspective, let's say, what could be practical difficulties in this standard, and then definitely it will make greater impact if everyone writes from their own perspective, right? But it is required that we must spare time out of our busy schedule and send our valuable comments to BIS technical committee before the stipulated timeline, that is 25th June, right? Okay. Okay, so before we start, let me just make a small announcement. So we just launched a unique online course titled as RCC STR 001. The title is Design of RCC Structures. And this course was triggered from various queries which we have received from engineers, and the queries are are centered about differences in the different software. For example, if same kind of problem is solved, let's say in State Pro, RCDC, and ETABS, then there are different results which are being being encountered. So which software is correct, or let's say what are the fundamentals? So out of that, there are around 20-25 questions which we received. So based on those questions, we have formulated this course. So link is mentioned on the screen, so you can refer this link for more details. Okay, so let's get started now. Yeah. Okay, so let's begin our discussion now. Of course, please feel free to mention as many discussion points as you can. So, Dr. Subramanian Narayan sir is telling that this will increase the cost of construction enormously. Absolutely right. The way the seismic force is increased in the draft standards, it will definitely increase the construction cost. Yes, good evening, Ashutosh. And yes, and thank you for your message. Okay, Naresh is telling that damping factor for bolted steel structure being used as 5% instead of 2% as mentioned in IS code, taking a reference of a ACI code. Okay, so likewise, please feel free to mention the discussion points in the live chat. Right. And we will discuss all this point towards the end of the session. Now let's have a quick view of IS 1893 part 2, where we had a quick look of IS 1893 part 1. So if you could not attend the first session of part 1, then the entire recording is available on YouTube. You can refer that. Okay, so just let me share the screen now. Okay, so I hope you are able to see the screen now. This is IS 1893 part 2. Okay, so I'll again highlight this point as we discussed, that we must examine this draft, and we need to state any difficulties which, let's say, we may encounter or experience in our business or profession if this is finally adopted as national standard. So we must send our comments related to practical difficulties to PIS so that they can make appropriate changes in the document. Okay, this is the format which we discussed. So you can refer the first part. Forward is almost similar, wherein it is said that the different standards are being formulated, and here in this portion it says that what are the changes made. So firstly, in this document, provisions are now added for the masonry building as well as for the steel building. Okay. And here it quickly summarizes the major changes which are proposed in this document. The response reduction factor have been modified, and now it is renamed in the entire document as elastic force reduction factors, as we discussed in the part 1 also. Now this is important point. The importance factors actually have been adjusted in view of the revision in the hazard levels. So as we discussed in the part 1, that now hazard levels have increased, and to adjust the total value of the shear force, the importance factor values have been adjusted. So if we'll compare the importance factor value of the draft standard and the present code, we'll find that the importance factor values are lower. Then provisions on the torsion has been improved. So we'll see that what additional provisions are added now for the torsion. And then provisions on buildings have been harmonized from relevant provisions given in 4326, 13826, 13827, and 15988. The section 2 additional criteria for masonry buildings are now added in this document. So provision on buildings have been harmonized from 4326 and IS 15988. The admissibility of different structural system in the earthquake zone is clarified. Now these are again two major revisions for concrete buildings. First of all, the admissibility or, or let's say which structural system we can provide in a different earthquake zone, that is clarified, or we can say it is mentioned in the table. And the structural plant density of the structural walls is now varied with the earthquake zone. So in the present standard, the structural plant density is constant, but now in the draft standard, it is proposed that it will vary with reference to the earthquake zone. And for steel structure also now criteria are added. So new provisions have been prepared for steel buildings. I think this point number B looks as a copy paste because structural plant density is not applicable for the steel structures. And these are the various standards which are referred while preparation of this draft document. Okay, so always forward is very important part wherein we will get a quick view of the document without getting into the final parts, final clauses. So as we all know that part 2 is for building kind of a structure, and this draft document is talking about masonry building, concrete building, and steel buildings. Terminologies are added now. So I have highlighted a few important terminology which we'll see. So for the base, now it is defined that for buildings with basement, it is considered at the bottommost basement level. Okay. And for buildings which are resting on pile foundation, it is considered to be at top of the pile cap. For the raft foundation, it is considered to be at top of the raft, and for footing, it is considered as to be top of the footing. There are definitions which were there in the earlier document also. The definition is added for core structural walls, perimeter columns, outriggers, and built truss systems. Okay, I think this is one of the provisions. So I have highlighted the important points based on my quick view of this document. Still, I'm referring this document. So let's say if you have find additional points, please populate it in the chat box. If time permits, we'll discuss it today, or we are planning a couple of more sessions. In those sessions, we will be again discussing all finer points which we might have missed out. So for height of the building, here it says this was common question which we were receiving, that what should be height of the building, wherein let's say the basement is provided in the building. So what it says here, the height of the building from its base to the top of roof level, that's okay. Now in this para it says excluding the height of basement stories. If basement walls are connected with the ground floor slab, or basement walls are fitted between the building columns. So what it says, if the basement walls are connected with the ground floor slab, that is first condition, or basement walls are fitted between the building column. So in that case, the height of the building needs to be considered excluding the height of basement stories. Okay. And then in the second case, we need to consider the height of the basement stories when basement walls are not connected with the ground floor slab and basement walls are not fitted between the building columns. Okay. And for the step back buildings, it shall be taken as the average of the heights of all steps from the base, weighted with their corresponding floor areas. And then in buildings founded on hill slopes, it shall be taken as the height of the roof from the top of the highest footing level or pile cap level. So there were a number of questions which we received earlier for the step back kind of a building. If this approach is used, then we received this feedback that the time period, whatever is derived with this averaging of height, is not appropriate. Of course, this is the feedback which we received from few practicing engineers. So I'm just highlighting it. Okay, these are different systems. Okay, now in the number of stories also, the same thing is mentioned, that it excludes the basement stories where basement walls are connected with the ground floor deck or fitted between the building columns, and it includes the basement stories when they are not so connected. How the height of the building will have major impact in calculation of the time period of the building, right? And that will have impact on seismic demand of the building. That's why height of the building is very important parameter. Then terminologies are added for the masonry building, because now there's a new provisions for the masonry building which are added in this document. Concrete buildings, steel buildings. Okay, for steel buildings now the definitions are added for CBF, SCBF, EBF. CBF is concentrically braced frame, SCBF spatially concentrically braced frame, and EBF eccentrically braced frame. So we'll see this towards last part of the document. Now, in the higher seismic zone, it is said that only EBF should be provided. So we will discuss that point when we reach to that part of the document. Okay, so let's go down now. These all are symbols. Okay, it's said that the four main desirable attributes of an earthquake-resistant buildings are robust structural configuration, at least a minimum initial elastic lateral stiffness, at least a minimum overall lateral strength, and adequate ductility. Okay. Now, as far as irregularities are concerned, if you look at in this table, I think this is one more change, which is a torsional flexibility is one of the addition. Of course, torsion flexibility is divided from two criteria, which we'll see in the subsequent part of the document. And as I could see that all other irregularities are same as they were earlier. So re-entrant corners and vertical irregularities in plan irregularities. Okay, non-orthogonal panel. So what I have observed that the wording is almost same. If you have noticed that there is any differences in language for any type of irregularity, please mention it in the chat box. Okay, so this is the torsional flexibility here. Okay. Now, a building is said to be flexibly, torsionally, or we can say it's flexible from the torsional perspective. So this statement is already there in the present code. When natural period corresponding to the fundamental torsional mode of oscillation is more than those of first two translational modes of oscillation along each principal plan direction. So this statement is already there, right? And it is said that buildings with torsional flexibility shall not be permitted. Okay. So it is not permitted, right? And then it gives the definition of torsional irregularity. But torsional flexibility is again defined in the subsequent pages of the document. This is a flexible floor diagram, then irregular modes of oscillations, stiffness requirement. Yeah, there is one problem here. So in the stiffness requirement, the stiffness modifier are defined for three different types of structures: masonry building, concrete building, and steel building. Okay, so for steel building, as we know that there is no possibility of any crack formation, and that's why all factors are one. So no property modifier or stiffness modifier is required for the steel buildings. For masonry buildings, let's skip discussion at this point and let's focus only on concrete buildings. In the concrete buildings, if we observe the value, then value of stiffness modifier are same for the serviceability condition as well as for the ultimate condition. Okay, so this is not correct in my opinion. The value shall be different. And even if you refer IS 16700, these values are different for serviceability as well as for the ultimate condition. So this is one change which needs to be required in this document. Right? The lateral story drift in the buildings is now defined with reference to the zone of the building. So in the present standard, it is having a fixed value, right? But now the value is varying with reference to the zone. So we can see as zone increases, the permissible lateral story drift decreases. So for example, for zone number 6, the value is restricted to 0.0020, which may be quite stringent. Of course, we have not put any numbers, but I think this drift could be stringent because on one side, earthquake forces have also increased, right, as we were discussing in the earlier session. And similarly, on the other side, the drift, permissible drift value is also restricted in the higher seismic zone. Uh, and for zone 2, the permissible drift is 0.0040. Okay, so these are so for strength design, the horizontal seismic force will be derived using this formula. So we will derive the value of HT from part 1 of this IS 1893 document, and R value will be defined from this draft standard. Okay, and once H is divided by R, we will get the seismic demand, or let's say a design based shear, or a seismic coefficient, we can say. Okay, this is the table for now elastic force reduction factor. So response reduction factor terminology is now changed to elastic force reduction factor. So in this table, I have just tried to highlight where I could see few changes in this document. Okay, one of the change, if eccentrically braced frames are provided, and if they are designed and detailed as per document number 18640 so I think this is also draft document. It is not published yet. So for that, the factor is 5.5. Okay, one more value. This for the concrete buildings. If we provide spatial RC structural walls without boundary elements, in that case, now value is reduced to 4.5 from the 5.0. So even if you have provided spatial RC structural walls, but let's say the boundary elements are not provided. Right. So here in this short form, the NBE represents that boundary elements are not provided, no boundary elements. So for that, the response reduction factor is 4.5. On the other hand, if I provide spatial RC structural walls with boundary elements, in that case, it will become 5.0. Right? So this is one change which I observed here in as a as a reduction in the factor when boundary elements are not there. And buildings with moment frames and structural walls. So this is a short form which is given. SSWS is Special RC Structural Walls. NBE, that means boundary elements are not there. And Spatial Moment Resisting Frames. In that case, the response is 4.0. Right. And then when buildings with dual structural system, SSWS, that means spatial RC structural wall. NBE, that means boundary elements are not provided, and SMRF. So if it's a combination of spatial moment resisting frame and spatial designed structural wall, which doesn't have boundary element, in that case, the factor is 4.5. And if everything is same and if you provide the boundary element, in that case the factor will become 6.0. And for the flat slab structures, the factor is mentioned as 3.0. Okay, so these are a few changes which I could notice in the new terminology, which is elastic force reduction factor. Okay. So as we were discussing in part one, that now the seismic demand will be different for strength design and serviceability check based on the time period. So we need to check, or we need to calculate the earthquake forces separately for both the cases. Seismic weight of floors is defined, like how much reduction we can do in the live load. Okay, let's skip this part. Importance factor, as we discussed, that these importance factors are actually calibrated to for matching the value of seismic demand. Of course, the seismic demand, whatever we get from these draft standards, is significantly higher as compared to the present standard. But if we compare the importance factor value, then we could see that okay, then the importance factors are not increased. It's only the zone factors which are increased significantly. For example, let's say if we see here the critical lifeline structures. So for that also importance factor is 1 only. If we refer whether it's important structure or whether it is a normal structure, the importance factor is only 1. So that means actually the effect of importance factor is already included in the earthquake zone of factors which are introduced in part 1 of the document, right? Yeah, and even for special structures, we can see the factor is only 1. Then approximate fundamental translational natural period. So as we were discussing, the height of the building H. Okay, it is already mentioned here also that the height of the building, and this excludes the basement stories where basement story walls are connected with the ground floor deck or fitted between the building columns, but includes the basement story when they are not so connected. Okay, so accordingly height will be determined and will have impact on the time period calculation accordingly. All other buildings, okay. The minimum design horizontal base shear force is now defined from this formula, which is 0.625 into Z, which we'll get from the part 1 as we were discussing in the last session. So Z will be replaced here in this equation. Importance factor we'll get from this document, and R also will get from this document. So from that we can determine the minimum earthquake force, and in no case the earthquake force shall be less than 0.015 W. Yeah, then distribution of design horizontal base shear force is okay. And for the torsion, the design eccentricity formula are now defined for 3 different types of analysis. Or we can say the equation is changed. So if we are performing only linear equivalent static method, but for majority of the cases, this linear equivalent static method is not applicable. Most probably, or for the majority of the structure, we'll have to go for linear response spectrum method. So for the linear response spectrum method, the torsional or design eccentricity should be considered with this formula, which is 0.05 times BI, where BI is the floor plan dimension of the floor I perpendicular to the direction of force. And this is one new concept called torsional flexibility of building. So torsional flexibility is already included in the upper part of the document, which we were discussing while looking at the section of torsional irregularity, right? So again, torsional flexibility of building is mentioned here, and the one equation is given here, which xi equal to this equation, okay? And this could lead to additional practical difficulty to derive this torsional flexibility, right? Because it requires certain parameters to be derived, like r, small r we can say, or it's a translational radius of gyration of the mass of the building at the floor level, and rk theta, which is the torsional radius of gyration of the mass of the building at the floor level. And this tau is the ratio of natural periods of the fundamental torsional and the fundamental translational modes of oscillations. So after replacing all the values, if xi is less than zero point 0.4, the building is said to be torsionally stiff. Else, it will be termed as a torsionally flexible. So now there are two definitions for torsional flexibility. One definition was already included in this document in the upper part, and now again definition is given for torsional flexibility, right? And there are two cases: buildings with rectangular regular plan geometry. So mostly will fall in this category: buildings with non-rectangular irregular plan geometry. So in torsional flexible buildings, the buildings shall be reproportioned to ensure that the xi is less than 0.4, right? So this could be additional practical difficulty for adjusting this factor. And first of all, how to calculate this factor, that also needs to be defined in detail, maybe with worked out examples. And here it says the shows the design limit for ek divided by b and tau for rectangular regular buildings. So based on different limit, the prescription is given, like let's say perform torsional analysis, or let's say revise structural system, etc. So based on this table, we'll get the direction, or we will get the instruction, we can say, that what could be next step. So this could lead to additional practical difficulty, because already it is said that the torsional mode, the torsional mode shall not be first mode. So it is already established in the earlier part of the document. So that is one part which we have to fix. And after fixing this, again, this detailed calculation needs to be performed for ensuring that the building is torsionally stiff. Okay, here in this part, commentary is given that what is the basics and intention for behind this clause. But I think this torsional flexibility could be clubbed in the one clause only, wherever the clause of time period is given. So requirement could be clubbed just only in one paragraph. Deformability or requirements, which is separation between adjoining units, it was there in the previous document also. Okay, for the structural analysis, as we discussed, that linear equivalent static method would not be applicable in majority of the cases, we can say, because it's applicable only for regular structures and with approximate natural period less than 0.4 second. For all other cases, we have to go for linear dynamic analysis method. Okay, and then it defines the steps for response spectrum method as well as for the equivalent static method. Okay. This paragraph is talking about scaling of the earthquake force, which is there in the present code also. And effect of masonry fields infills is to be considered as it is mentioned in the subsequent pages of the document. For buildings which are constructed on the sloping ground, so for those buildings, additional provisions are given or proposed in the draft standard. So these are buildings which are constructed on the sloping or let's say on a hilly region, or we can say on the sloping ground. So this is new provisions which are added in this document. And it also suggests the RC wall configurations for the buildings on the hill slopes. Okay, now for the foundation, it says that isolated RC footings without tie beams or unreinforced strip foundations shall not be adopted in buildings rested on soft soils, which is site category D in any earthquake zone. So what it says that if site category is D as per IS 1893 part 1, in that case, tie beams needs to be provided for isolated RC footing in any earthquake zone. And then there is one more statement. Use of foundations vulnerable to the significant differential settlement due to ground shaking shall be avoided in buildings located in earthquake zones 3, 4, 5, and 6. And individual spread footings or pile caps shall be interconnected with ties except when individual spread footings are directly supported on rock. In buildings located in earthquake zone 5 and 6. So these clauses are identifying or mentioning tie beam requirement at foundation level for arresting the differential settlement. Then the projection, cantilever projections, vertical projection, and horizontal projections are mentioned. Compound walls is okay. It's already there in the current standard. Okay, there's architectural elements and utilities, which is AEU, is the new addition in this draft standard. So here it identifies the design requirement. Okay, like DAEU supported consequently at two levels of the same structure, one at height H1 and other at height H2 from the base of the structure shall be estimated as equivalent static linear analysis and with the linear dynamic analysis. So here worked out examples may be there which clarifies the concept which is mentioned in the document. Okay, this next para is also talking about AEU elements. Okay, section 2 is for additional criteria for the masonry building. So for this masonry building, still I'm going through this document. I have not studied it in detail, but if you have certain observations in this, you can please mention. Just one thing I wanted to highlight. Okay, so here it says that for brick masonry structures, structural analysis by hand calculation is feasible for single-storied simple configurations that are regular in plan and in elevation with minimum torsional eccentricities. So this paragraph is written for the masonry building. So for more complex configurations of masonry buildings, alternative approaches shall be adopted as equivalent frame modeling or finite element modeling. Okay, then it identifies how it may be done. Okay, additional criteria for the concrete buildings. Okay, dual systems. So it provides a stable, like admissible structural system in RC building. So if we have zone 2, and it could be OMRF, SMRF, or SMRF plus SSW. So on the top part, it is talking about different categories of the building, like normal, important, critical, and lifeline. Okay, and on the left hand side, different earthquake zones are identified. So here, from here we can see if we get into zone 5 and 6, then it's only dual system which is allowed for any kind of building, whether it's a normal, important, or critical and lifeline. And for zone 4, it is SMRF plus SSW. So shear wall or specially designed structural wall is must when structure is in zone 4. And if it is in zone 5 and 6, then dual system is must. And as we were discussing in the forward part, that now minimum structural plan density of structural walls are revised, or rather it is defined with reference to the earthquake zone, and that value varies from 1.0 to 2.5 percentage. In the present standard, this value is 2 percentage. Okay, so it is increased to 2.5 percentage, right, and decreased to 1.0 here. And then spatial buildings. In residential building up to 2 stories, including basement and located in earthquake zone 3 and 4, equivalent static analysis is permitted, and the structural system shall be at least SMRFs with infill walls in last or in at least 90% of the base, right? Okay, so this way clauses are mentioned, and if the building is in earthquake zone 4 and 5. So these clauses are for the small buildings. So for earthquake zone 4 and 5, equivalent static analysis is permitted, and small buildings are defined as a residential building up to 2 stories. And since building is in earthquake zone 4 and 5, The structural system shall be at least SMRFs with infills with SSW with at least 1.5 percentage structural plan density in each principal plan direction. Okay, this is for open stories. Then braces, okay, unreinforced masonry infill walls. So wherever a masonry infill is provided in the concrete buildings, and as it is mentioned in this document, the effect needs to be considered. Like, let's say if we just go to the upper part, in RCMR buildings and unreinforced masonry infill walls, effect of in-plane stiffness and strength of URM infill walls shall be considered on story stiffness and story strength of the building. And when variations of story stiffness and strength along its height render the building to be irregular as per 5.1, as it is mentioned in the paragraph for the soft story, the irregularity shall be corrected, especially in members of RC MRFs, sorry, especially in earthquake zone. Okay, it is continuing here in the earthquake zones 3, 4, 5, and 6. And the members of RC frame MRFs shall be designed for the more severe of the combinations of stress resultant arising of two structural analysis model, bare RC MRF building alone and RC MRF building with URM infills. So even in the present code, this kind of statements are included. Of course, in the amendment, this requirement was added, as I remember, and we experimented this clause on few buildings, and we could find that there are a number of practical difficulties when we include this infill, masonry infill, as it is mentioned in this document, right? Of course, that's because of certain limitations of the software. Okay, in the section number 4, it's talking about additional criteria for the steel buildings. The structural system, the admissible structural system in the steel buildings. So here, as I was just telling in the initial part, like, so if structure is, any steel structure is located in zone 5 and 6, then it's only EBF which is permitted. So this requires I think reconsideration, according to me, because SMRF may be equivalent, right? And it could lead to so much practical difficulties also, because EBF is not at all used in, according to me, in our country presently. So let's say if suddenly if it is required to be used in all the zone 5, then it needs to be thought from that perspective also. Okay, but in short, this table identifies the additional, or rather admissible structural system for steel structure in different zones and considering different categories of the building. And even if we refer here in zone number 4, SCBF is not permitted. So that also needs to be critically reviewed according to me. The SCBF, which is spatially concentrically braced frame, and it is used actually extensively in the industrial structures, in very very heavy industrial structures. SCBF has been used in heavy seismic zone, and spatially concentrically braced frame, actually that is the most, we can say, rigid frame or rigid structure which is available out of these three frames, right? Okay, so here it identifies spatially concentrically braced frames. So I think we can expect few more draft documents which will be coming up, which will define the requirements for spatially concentrically braced frames. Right now, it is defined in Section 12 of IS 800 2007. For steel structures also, the spatial building clause is written wherein small building is added, and in residential buildings up to 2 stories and located in seismic zone 3 and 4. Okay, I think the same paragraphs are reproduced, but here in the first part, in zone 3 and 4, it says SMRFs with infill walls in at least 90% of the base, and in the zone 5 and 6, the structural system shall be at least SMRF with SCBFs and EBFs in each principal plan direction. Steel buildings with the open stories. Here it says that the braces, whenever they are provided, shall be continuous over the full height of the building. Okay, raised paragraph are okay. Okay, good. Okay, so it was a quick discussion about IS 1893 part 2, and I just tried to highlight few of the points which I have noticed while going through this document. Still, I'm going through this document, and please share your observations also. So right now, I have just opened discussion points which we have received through the registration form, and it's running 500 plus points, but I'll just touch upon few points. Okay, that please explain why seismic zone and response reduction factor is somewhat higher than the previous 2016 code. Of course, it requires uh, detailed discussion on this, and there are number of queries we have received on this part, that why these seismic zones have increased. Okay, so for these, whenever we find or rather whatever questions we have, we must write to the BIS technical committee. The Sachi Parekh is telling that structural configurations always plays a very vital and important role, and just by speaking about plan irregularities, the code remains silent or is sufficient enough to take care of safety. Okay. Shubham is telling that why zone 6 has been introduced. Will structures be modified for the new zonal classifications? So what will happen to the buildings which are already constructed? Okay. And Chandrasekhar is telling that presently, as it's most of these G plus 5 story buildings in city like Hyderabad are being constructed without seismic analysis. Now, with introduction of more rigorous analysis process without an explanatory handbook, absolutely right. If explanatory handbook is not available, and with this kind of a complicated documents, in fact, the design calculations could go on either side. There are all possibilities that the calculations could go on the unconservative side also, because of so many complications which are being added in the document, and in the absence of explanatory handbook, definitely it would be very very critical. So, okay, Varsha Kanetkar is telling that small buildings criterion seems dependent on number of stories only. Is it dependent on the floor area coverage, floor height and beam spans? Auditoriums and a large community centers like structures can they be called as a small buildings? Okay, so the first query, the small building clause which is added in the draft document, it's only for the residential buildings. So it is not applicable to the auditoriums and large community. Also, your point is absolutely right. That clause cannot be applied to the auditoriums or large community halls, which could be of 2 stories, and they cannot be considered in any case as a small buildings. And then second question, zone of map of Maharashtra has additional zone added. So why additional zone is added? Okay. Then Rahul is asking applicability of soil stiffness calculations modulus of subgrade reactions on bridges designed by other codes, right? So right now I'm just touching upon a few points. Of course, we will try to discuss all the points in more details in the next couple of sessions. But right now I'm just highlighting these points so that others can also think in this direction while formulation of the comment. Okay, Hiren Bhai from Surat is telling that the reasons for revising zone of the South Gujarat near Surat. So now Surat is placed in zone 4, right? So that's a question that now why Surat is replaced from zone 3 to zone 4. Okay, Rajan is telling that all parameters affecting the base shear calculations need to be discussed in depth, right? As there are large changes made in the zone factor, importance factor, time period. Yes, absolutely right. Jay is telling that most of the provisions seem in line with the ASC 716 and UBC, and also the seismic provisions for non-structural elements were much awaited. However, the PGA derivation seems to be on the higher side. Also, the categorization of seismic forces to be considered for SLS, ULS, and serviceability is of main, let's increase what it says, is of main interest. And it would be great if we can compare with the other international codes, right? But let's say if you have certain, if you've experienced certain anomaly, or if you could experience certain, let's say, practical difficulties which may occur in the future, then please write to the BIS technical committee. Okay, Dr. D. Hanumantha is telling that design of EQ zone factor is substantially increased, right? So justification for increasing to be discussed, right? And that's this point. Obviously, we all must write to BIS technical committee that why substantial increases made in the seismic or earthquake zone factor. So there are a number of points which are highlighted on that direction. Okay, Sailesh Gupta is telling in 1893 draft for calculating time period for high-rise building, shall 16700 draft formula to be used as a draft formula of 16700 gives higher time period, and as compared to 1893 2016 formula, and now in the draft Z value is increased. Yeah, so that's right. Now there are so much revisions happening, like for 16700 also draft was there. Now, in fact, recently we had draft of IS 1893 part 4 also. And now the draft of this 1893 part 1, part 2. So your point is right. There are so many changes are being made. Okay, Arpat is telling that how to make a steel structure ductile. As far as RCC is made ductile by some clauses of IS 13920. For steel structures, we don't have special codes. So those codes are being in formulation as it is mentioned in the forward of the document. And we will again receive draft codes of such documents. Okay, Debashish Bandyopadhyay is telling, is it possible to include the following points for design consideration of earthquake resistant structures, duration of earthquake, and frequency content of earthquake. So he's adding a couple of more interesting points, that what is the duration of earthquake and frequency content of earthquake. Right now this details are not added in our draft standards. Gaurav is telling the revised draft for 1893 part 1 and part 2 has updated the calculation of base shear, but it seems that reducing values of for the other factors, they have not made any significant change. All the values in the code appear to be arbitrary, and the base shear has been increased by 2 times. Please let me know if there are any corrections in this statement. So your observation is right. The force is increasing by 2 times, but the increase of the force actually it varies from the based on the seismic zone. So as seismic zone increases, the base shear increases, or relative increase in the base shear is higher as seismic zone increases. And in the next line, he says that, however, if they are altering such a significant amount of values, it is crucial that they publish the relevant supporting data in the drafts. Without this information, it is difficult to verify the numbers on our end. Is it only our responsibility to check for spelling mistakes? Moreover, with the publication of AC 722, it is highly or it's likely that our IS codes will also be changed in 2023 as a coincidence. Yeah. Okay. So he's making a couple of interesting points here, that first of all, the rationale behind all the changes must be available along with the draft documents. And if AC is let's say recently revised, so whether it will have impact on our current standard. Okay, Sauraj is telling, I'm quite surprised for the sudden increase on the values in the seismic force. Amarjit Singh is telling, changes such as zoning, zone factor, separate analysis for serviceability and design, and then wide dependence on soil consultants with borehole depth as 30 meter, among others. Okay, Mahesh Dhere is telling, need to get more clarity on newly added seismic zones and design considerations with respect to time period. Okay, Suresh Kumar is telling, necessity of higher grades of steel and its advantages and disadvantages with reference to the earthquake resistant design. Okay. Dr. Rana Pathak is telling, on what basis the zones of some cities like Indore have been reduced from zone 3 to zone 2? Is it safe for the developing cities where unplanned and non-engineered construction is taking place at a very fast pace? Okay, Sunil Gandhi from Rajkot. He said that earthquake zone map revision is questionable, particularly where the city is updated to zone 4 from zone 3, like in Gujarat, where Rajkot and Surat cities are updated to zone 4 from zone 3. While the Ahmedabad is kept in the same zone 3, which experienced maximum damage in 2001 earthquake. So he's from Rajkot, and looking at the performance of buildings during 2001 earthquake, it does not require higher zone map in 10 city. And the micro zoning of map is further needed. Okay. So there are maximum questions on the earthquake zone and increase in the seismic shear or design base shear. Okay, Nikhil is telling clarity on the load combinations. And why and how the strength and serviceability modifiers been kept identical, right? We discussed this point. They shall not be identical, they shall be different. And he's taking about one more point. We need to check this clause. So he says that how for realistic this formula would be for building even up to 50-meter height. Is there any international or national literature that would second use of this formula for say a 15-storied buildings? Dr. Ajay says that for various cases designed as per current code and draft code, there is no uniform increase or decrease. No, let me just stretch it. Okay, no uniform comparison can be made. Right, as we just discussed, the variation is not constant. It varies with reference to the category of the building. It varies with reference to the uh, seismic zones. Okay, Santosh Biraj is telling that these changes should be routed through municipal bylaws and made mandatory for statutory approval. Whatever the size of the building, then only engineers will get more employment and will not be questioned unnecessary. Okay, Chinmay Sarkar is telling how easily we can adopt the new provisions of the code in our design. What effort should be given for this adoption? So that's what we are discussing, that it will require significant amount of effort and practical difficulties would be involved if the documents are accepted as it is. Okay, Vishal is telling as a large number of structures are already constructed with the previous version of the document in every corner of the country. So it is recommended to retrofit to the structures for such new forces. Right. So his question is what will happen to the existing structures which are executed with reference to the earlier codes? Okay, Paras Goel is making note about design of factor of safety against soil liquefaction, which is specified as 1.4, and according to him it appears as a conservative. Okay, Satvik is telling that why a new zone is introduced, and is it based on any experimental study or the performance study of the existing buildings in that zone? Would like to know more about it. So in the you can refer IS 1893 part 1 in the appendix, as well as in the forward brief description is given that what methodology was adopted, but the sudden increase with such a magnitude is not at all justified. And second, what is the rationale behind having different Z values based on the written period? And when we already have the importance factor I to take care of it. So now if we see the actually importance factor is becoming 1 for all buildings, for majority of the buildings as we were looking in the part 2. So you're right, more or less now actually I will become obsolete now. It doesn't have any impact in the calculation because it is having value as 1. Kevupulla Raju is telling elaborate combined effect of different sets of stiffness modification factors with various building plan aspect ratios on time period for the mid-rise, high-rise and tall buildings, and seismic responses for bare frame RCC structures. Okay. Ram Prasad is telling, as per draft document, it will be very difficult to implement the codal provisions. Some of the clauses are not clear. That should be explained clearly, right? Okay, Padam Kumar is telling that there are a lot of changes. Yes, indeed, there are significant changes made in this draft standard. Okay, Manohar Mate is saying that IS 1893 Part 4 draft revision was circulated early this year. Late year 16700 for tall building was issued. The proposed draft has many new provisions, including change of approach in assessment of earthquake actions from earlier deterministic to probabilistic one. The new approach gives considerably high story and base shear for most of the locations in Zone 3 and above. This is more predominant at places in newly formulated Zone 6. How to estimate structural safety and stability of structures designed based on recently published IS codes as listed above, and also designed as per present 2016 version of IS 1893 Part 1 in case it requires any retrofitting, and how to handle such situations. The new draft emphasizes that this shall be followed as possible in case of ongoing works. Okay, Rajnikant Parmar has mentioned an interesting point that why can't a particular section of this code and 167002 be addressed to the architects for the clauses governing in the geometric parameters of the buildings like slenderness ratio, irregular plan shapes, vertical irregularities, soft stories, etc. Okay, yes, Dr. Subramanian Narayanan sir is telling that how the stiffness reduction factor may be same in the strength design and serviceability design. The structure itself is designed for 60 to 75 years, bridges maybe for 100 years. Then why should we consider a written period of 2975 years? Is it not ridiculous, right? So we are designing our structures, let's say, for generally building for 60 to 75 years. Then why written period of 2975 years is considered, right? That's absolutely right. And it's actually because of the this written period, the intensity of the earthquake force is increasing significantly. So as we reduce this written period, the earthquake force intensity which we need to consider for the building design will definitely come down. SV Gopal Krishna Rao is telling that R value comparison between old and draft code in regarding the zone factor and overall additional resources for RCC structures as per the draft code. Okay, so I've just touched upon a few points. Still, we are going through this document. We can see here 530 plus points which we have received. Okay. Okay, so Dr. Subramanian Narayan sir is telling that this code makes all old structures and also the structures under construction as unsafe. So you're right. Let's say if this document is published as it is, then all old structures or the structures which are in construction will become unsafe overnight on paper. Case, Engineer Naresh, the code writers are interested in including only complex things in the code. Then how will they introduce rectangular stress block? So this is the important point. Like while writing the code, they should focus on simplicity, so that, and if it is as simple as it is possible, then the chances of errors will be actually minimized. Okay, Kali Prasad VS is telling what is the design life of the structure as per the code. So the same question we were talking, like the design life could be 50 to 75 years, or for the bridge it may be 100 years. Right? Stiffness modifiers should be different for serviceability and strength, as one is checked at working loads and the other is at the factored loads. Absolutely right. It must be different. And actually, if we consider the stiffness modifier value same for both the conditions, then actually our design is actually erring on the unconservative side. So I've created few study models for that. And if we consider the same values of stiffness modifiers for both the conditions, then actually the design will go on the unconservative side. So that's why these values must be different. AHT given for above ground and below ground means height of the building considered from below ground. Yes, your question is not clear, Prakash. If you can just elaborate it, then we will take it up. Okay, why is the importance factor included in Z? It is not fundamentally wrong. Yes, absolutely right. It is fundamentally wrong. And when we see in the part 2 document, all importance factor values are 1. So for calibration, if calibration is required, because now this document, as we understand, will be divided in several parts, 10 to 11 parts, right? So inclusion of importance factor in the zone factor is fundamentally wrong, because there will be n number of different type of structures which will be coming. So the zone factor must be independent of the importance factor. Okay, I think building important given in building set, right? Rahul is telling table of importance factor, buildings not listed below I is equal to 1.15. It is doubted whether that not was intended, or is there be my mistake? Yes, maybe. Yes, Rudra Nevatya sir is telling what does perform torsional analysis mean? So I'm not sure what does it mean, but it may be referring to that torsional flexibility check, right? So I'm not sure, but your question is right. It needs to be elaborated in the document that what is the meaning and intent of perform torsional analysis, because there is no separate analysis available in software as a torsional analysis, right? Okay, Prakash is telling great work in torsional irregularities means EK by B, and torsional mode is direct relation. We'll always try to coincide center of stiffness to center of plan or mass. 0.9 only possible EK by B in the limit. So that is one more check which we need to do. Torsional analysis is same as response spectrum analysis. So it's not mentioned in the document. Okay, does perform torsional analysis mean perform 3D analysis by whatever method? Yeah, so maybe we are not sure about this. Okay, Dr. Subramanian Narayan sir is telling residential building of 2 stories including basement means the building with basement plus 2 stories, it should be changed to 4 stories, right? Yes, and regarding torsional analysis, there are a lot of confusion, and the provisions are based on one researcher at IITM. Okay. Okay, Subir Mandal. So thanks for such open discussion. Yes, most welcome. The code talks about changing the configuration if the conditions are not satisfied. Most of the configurations are fixed by architects and not by us. And that's very important point, because we do not have that much flexibility or liberty in many of the cases where we can change the configuration. Okay, we compared 1893 and draft 2023, and is it compared to New Zealand or ASC or Euro or Chinese codes? Where is IS code compared to international codes? Okay, regarding structural life, I feel that the code should not talk about it. If it is mentioned, there will be a number of court cases against structural engineers. Yes. Okay, it does. And when they introduce drastic changes in the clauses, they should say why it is changed and what is the basis. Yes, that's what is required actually, along with the draft document. The rationale behind all changes, it's only added for couple of clauses in the document. So instead, that should be detailed document which identifies a very the first of all the changes which are made in the document along with the explanatory document, and also it identifies along with the practical examples, let's say how we can adopt it in the practice. So then very easily we can take a call and then we can prepare our comments. Yes, most welcome, Dr. Ajisha. Okay. So Dr. Subramanian Narayanan sir is telling, I request all 530 people who have signed comments as well as others to sign their objections to BIS committee as soon as possible. So that's what needs to be done as a next step. Everyone must write comments to BIS technical committee. Yes, and I think other country codes are simpler than this draft code. Yeah, so one of the reason is the other country code. Firstly, they have explanatory notes available along with the worked out examples, so that it becomes easy for understanding and for implementation. And for the software developer also, it becomes relatively easy for preparing the software. So in case of ambiguous clauses, of course, software developer will also not have much clarity. And finally, then it is left to the practicing engineer, like how to deal with the situation. And that's why we find our documents are very difficult to implement in the real projects. It clearly shows that this draft is prepared by theoretical persons who do not understand the practical difficulties. Yes, absolutely right. Okay, so thank you all for participation in this session. Okay, so all are requested to send their comments to BIS as soon as possible. The last date is 25th June 23. And before that, we are still planning to arrange a couple of more sessions on this important document. So wherein, let's say, if you have formed your comment, we will also discuss your comments also. Right. Okay, so yes, you're most welcome, sir, and thank you. Thanks a lot for participation and for raising very important discussion points. Okay. So with this, let us close this session, and very shortly we'll meet with a couple of more sessions for this IS 1893 Part 1 and Part 2. Right. Okay, Rahul is telling, is there any way we can get the probabilistic earthquake hazard study report? I'm not sure. Is it available to us? Right. So as I can see that still comments are popping up. So what we can do is you can still connect with us separately for discussion related to this document. And very soon we will be announcing the couple of more sessions on this before 25th June. Okay, so that it will be helpful to all of you for formulation of your comments, and you can also look at the comments which are made, let's say, by other engineers, so that, let's say, the important points are not missed out while sending the comments to the BIS technical committee. Okay, so with this, let us close these sessions, and we will meet shortly with a couple of more live sessions on this 1893 part 1 part 2. Okay, goodbye.